Welcome back. So in this section we will introduce yet another quantity called power. So why there is actual need to understand a new or introduce a new quantity called power? Does that mean work done? The quantity work done is not always sufficient in describing all the real life situations. Certainly yes. Because if that is insufficient, if the quantity work done is insufficient in describing all the situations at hand, then only we will have to introduce a new quantity. Otherwise, we would have happily used work done itself. So let's find it out. So we have shown a situation here in which there is a contractor who has taken a contract of building a house. Imagine a situation in which workers are taking a time of 10 years for building a simple house. Will that be practical for that contractor as well as for the owner? Certainly not. Contractor and the owner of this house is interested not merely in the work done, but they are interested in the amount of work that is being done in a particular amount of time. So they want the work to be completed in a given time frame as well. So in this situation, can we use work done alone to describe this situation? No. Here we will have to include a time frame with the amount of work done. Consider the second situation. You might have seen a locomotive engines, at least in the movies. So these locomotive engines actually converts the chemical energy stored in coal into the mechanical energy, and that mechanical energy is getting utilized for the motion of this train. Okay, so this person actually throws amount of coal into the engine so that the actual conversion from chemical energy to mechanical energy takes place. In this situation as well, since this person is doing some amount of work, but is it merely sufficient that he is doing work? No. If consider a situation in which this person is throwing a particular amount of coal in an interval of 10 minutes, then will this train be able to move at a particular speed? No. So this person has to take into consideration the time as well while doing his work. So he must be doing his work very quickly. That means we have seen two situations here in which we can see that merely work done is not sufficient. At some situations we will have to take into consideration the time frame as well. That's what we are trying to convey. There could be n number of such situations in our real lives where work done is not sufficient. And that's why we have to introduce a new quantity called power. That's why it says sometimes doing work is not merely sufficient. Rather, we are interested in knowing how fast that work is being done. We have already seen the two examples. Time along with work becomes important, and power is the quantity which provides insight into time spent in doing work. So power is the quantity which connects the dot between the work done and the given time frame. So let's see how it connects the dot. In this diagram we can see that a force F is getting applied on object 1 and object 2. So due to application of this external force F, some amount of energy is getting transmitted from this object to this object. Okay, and we have seen that energy that is getting transferred from one object to another due to application of a force is nothing but work done by that force. So we have already seen that work done, but this time we are interested in the time factor as well. So let's define power. So power will be equal to work done divided by time interval. If we elaborate this quantity, we say that power due to a force or power of a force. Because force is the only intermediate quantity due to which these transactions of energies are taking place. So who is responsible? Force is responsible, and hence power, whose power we are going to discuss? Power of that force we are going to discuss. So power of a force will be equal to work done by that force, divided by time taken in completing that work, okay. That constitutes a quantity that we are discussing about, that is nothing but power, okay. So there could be two description of this quantity. The first one is average power, and the other one is instantaneous power. So both these quantities are power only. So what's the difference between these two? The first one, average power, deals with a macroscopic time interval. That means a time interval that we can quantify or that we can realize. For example, 5 minutes, 2 minutes, 3 minutes, that we can count easily. For a microscopic time period, the power or the average amount of work done getting transferred is nothing but average power. However, instantaneous power is nothing but power delivered at a particular instant in time. So how much power is getting delivered at time t is equal to 1 second or time t is equal to 5 seconds. So it's a kind of instantaneous power. So average power is defined as P average is equal to nothing but average work done divided by delta t. Delta t is nothing but the time interval in which we are interested in finding the work done. Similarly, instantaneous power will be defined as P will be equal to dw by dt at time is equal to t. So at a particular time t, how much amount of work done is getting transmitted, how much energy is getting transmitted, is called instantaneous power. So these are the two quantities that we are going to discuss. We will discuss further.